Welcome to another Deckside video. As we approach this particular um, heater repair job, you'll notice the correct vent stacks on the outside of the building. You'll also notice an upper and lower airflow, which is very important to make sure we have enough fresh air makeup into the room for the heaters to operate properly. Now, in this particular video, note that the heater on the right is very close to the wall, and so in order to gain access to the heat exchanger to perform the repair that we're going to do on this, we're actually going to have to uninstall the heater and then rotate it 90 degrees. So this particular heater we had determined in our annual heater inspection that the heat exchanger was sooting up, and that the cause of that was calcified tubes, and this was also reducing the efficiency of the heater. You can see there still is some evidence there of the heater sooting. Now that sooting is unburned fuel from an improper air fuel mixture in the combustion cabinet. And as that black soot builds up on the heat exchanger, it causes a very acidic condition, which if left unchecked and not taken care of, will eventually eat through the copper heat exchanger and cause it to leak, therefore causing a catastrophic failure of the heater. So what you're seeing there in those series of videos was our technician removing all the connections. He's now rotated at 90 degrees. And you can see that the heater is open now. He has removed the header from the heat exchanger, those tubes that you see there. Okay, this particular view here is of the unitherm governor, and we're going to expand on this a bit more in a second here. But you're looking inside of the header. We're examining the bypass valve and unitherm governor. What you're seeing there is evidence of a lot of scaling and calcification inside of the header. This is blocking the water flow and preventing the heater from operating properly. More evidence of the scaling and calcification. The scaling can be brought on by a number of factors, which can be partially out of balance water chemistry. This usually occurs in situations where we do not have water chemistry controllers controlling the water 24/7 and are simply relying on manual dosing 2 or 3 times a week. So with the professional water controllers, we can eliminate or reduce the amount of scaling that you see. You see what that does. Now this particular bypass valve, this is normal for these to wear out about once a year. We will get in there and replace these. This is a part that just normally wears out. That's soft brass. Now, what you're seeing there, those white rings, is actually the scaling and calcium that is built up on the inside of the heater tubes. What our technician is doing now is using a drill, which will follow up with a special burr, and he's actually drilling out that rock hard calcium. That's just the stuff as hard as a rock. He's drilling that out to allow the water to flow again properly through those tubes and get the heater back up to its proper efficiency and working properly, and to prevent further sooting. You can see how hard that can be at some point in time. This whole process that you're seeing here in a matter of minutes usually takes about a half a day to do all this work. So here he is cleaning the tubes, continuing to clean the tubes, but he's also replacing the rubber gaskets. We're putting on a new high temperature, this is a safety switch. It's what we call a high limit switch. It senses if the water gets too hot and it shuts down the heater. It's called a high limit safety switch. So it's typical another thing that we replace. They wear out. So he's reinstalling the header. All the new components have been put back in. The tubes have been cleaned out. And as soon as we get this back together here, rotate it back in place, hook it all back up, we'll be ready to do a test fire on this particular device. See, the heat exchanger is back on. This is about a 300-pound heater, but you can manage to scooch them around, you know, not too bad. So he'll very gently move it back into place. Once he gets it all lined up, he can rebolt it back on, reconnect the electrical, reconnect the vent stack, reconnect the gas, and double check to make sure everything is, you know, lined up properly. One thing we do at Deckside is we always mark the gas pressures when we do our inspections. We date it and sign it, and we put the pressures on there, which are very important to the operation of these heaters. Now he's test firing, and once again, good job. Heater's ready to go.